All right, so we are all set. Let's go straight to problem number 1. We are doing the 2020 round 2 senior paper for the session, and we are going straight to problem number 1. Okay, question 1. It says the sum of a 7-digit number is 6. The sum of the digits. What is the product of the digits? Okay.
Not working at all.
I'm sorry. Aisha, will you please put your speaker off? Thank you. So you got a 7-digit number and the sum of the digits is 6. So what does this mean? It means that you can't have all the numbers being greater or equal to 1. The digits are going to be 0, 1, 2, 3 up to 9. You can't have all the digits, at least 1.
Yeah.
Makagoni, please put your mic off. Okay, I'm sorry about that. I've muted her. I was saying that the digits are all at least equal to 1. If their digits are at least equal to 1, then when you add 7 numbers, they will be at least equal to 7. So, but the sum is 6. So this means that it is not true that all the numbers are at least 1. That means one of the numbers must be 0, and therefore the product will have to be 0. So the argument is that one of the numbers is 0. All right, so let's get on to that. So in this problem here, you are saying that one of the numbers is 0, one of the digits is 0, and therefore the product is 0. All right, so let's get on to the next problem. The next problem, question 2. The question says, now before I proceed, we put up the questions of session 1 on the web page, and I made an appeal that please look at the questions before coming to the class. I trust that all of you have done that. There would be some people who haven't done it, which is quite unfortunate because you are then now looking at the questions for the first time and you're getting the answers almost immediately and you're not thinking at all about the questions. So in which case you are not benefiting at all from this class. So please follow that instruction. Look at the questions before you come here. Then when you see the solutions, you would appreciate it. So let's get back to this. Question 2, how many of the first 100 positive integers are divisible by all of 2, 3, 4, and 5? Right, so if the numbers are divisible by all 2, 3, 4, and 5, it means that the LCM, the lowest common multiple of these, of 2, 3, 4, and 5, if you calculate it, you will see it's 60. Right. Now, if you got a number which is a multiple of 2, 3, 4, and 5, it has to be a multiple of the lowest common multiple. Right? The lowest common multiple literally means it's a common multiple, which is the smallest of the lot. So here you've got a number which is a multiple of all of these. So therefore, the number, it must be at least 60. all right? But you got a number, this number here is from 1 to 100. How many of the first 100 positive numbers? That's a question, right? So you're looking for multiples. The common multiples are all multiples of the LCM. So the common multiples are 60, 120, 180, and so on, right? And this is the lowest of the common multiples. So there's only one number, which is between 1 and 100, which is a multiple of 60. So the answer is 1. The answer is 1. 60 is the only one. The question is how many of the first 100 positive integers are divisible? There is only one. Okay. So that's the second problem. The third one, all right, so let's look at question 3. Question 3 says that Kerstin opens her dictionary and says that the sum on the number on the page I am currently looking at and the number on the next page is 341. All right. So on which page is Kerstin? Well, this should be, it's quite clear. What's going on here is that you've got, she's looking at a certain page and she's looking at the next page. So suppose she's looking at page n. Then the number on the next page is n plus 1. And the sum of these two numbers, she says, is 341, right? So she's looking at this page here. So we need to know what n is. It's 341, sorry. 300. If you take the 1 to the other side, 340. So she's looking at page 170. 170 plus 171 is 341. So that's the answer to that question. Okay, question 4. What is the smallest positive integer that you can multiply 2020 by to get a perfect square? Okay, so you are taking 2020 and you're going to multiply this by something and you're going to get a square number. And the question is, what is the smallest possible number you can get, right? And the way to do this is you need to factorize 2020. Well, 2020 is actually 20 times 101, right? You're going to multiply this by something to get a perfect square, okay? All right, the smallest one you can get is, you need to certainly multiply it by 101. You have to multiply this number by 101 to make this into a perfect square. Here you got 20. The smallest number that you have to multiply 20 by to get a perfect square, 20 is already 4 times 5. So 4 is already a perfect square. So what I have to do is to multiply this by 5 to create a perfect square. All right, so what are we saying? We are saying that we've got 2020 is 4 times 5 times 101. This is already a perfect square. So the smallest number you need to multiply it by, you have to multiply by the 5 to make that a square and multiply by 101 to make that a square. So the smallest number that you're looking for is 505. Okay, that's the answer to that question. All right, we go on to question 5. You can see I'm moving quite steadily with the early questions because these are not very demanding. All right, most of them involve numbers, all natural numbers and counting numbers. So question 5 is on 4 consecutive days, David woke up at 5:30, 5:45, 7:30, and 7:55, respectively. So on average, over the 4 days, how many minutes past 6 o'clock did he wake up? Okay. Now, there are a number of ways in which you can tackle this problem. Maybe the easiest way is where you just count these as times here. This is 5 hours 30 minutes, 5 hours 45 minutes, 7 hours 30 minutes, and 7:55. So you count these and divide by 4. That way you'll find the average. Right? How do you count them? You got 5 plus 5 is 10. 1 and 5, 6 and 3 is 9 and 4, 13, 16. So you got 160 minutes here, right? You're converting that to hours and minutes. So 160 minutes is 120, which is 2 hours and 40 minutes. So it's 2 hours and 40 minutes, and you carry the 2 over. And when you add these, now you get 2 plus 10, 12, 19, 26. So if you add the 4 times, you'll get 2640. And to find the average of these 4, you have to divide 26 hours 40 minutes by 4. Just remember, we're working with hours here. So 4 goes into 26 6 times. Remainder 2, you convert that to minutes, that will be 120 minutes, and add 40 to it to get 160 minutes. You divide that by 4, and you get 640. So this is the average time. And the question is, for how many minutes past 6 did he wake up? So he got up at 40 minutes past 6. So the answer is 40. You have to answer the question. How many minutes past 6 did he get up? Okay. All right, let me now just ask a question. And by show of hands, I would like to see how many people got this answer. The answer is 40 minutes. Right? You can raise your hand just to, I told you how to do it. You can click on the hand signal at the bottom of the screen. If you don't see the hand signal, go to the 3 dots on the extreme right and click there, and there you will see a hand signal. You can click there. So I'm happy to see that a fair number of people have raised their hands. Please, all of you, do what I asked you. If you have got the answer, raise your hands. All right, so those people who did not get the answer did not raise their hands at the moment. So we've got almost half the students got the answer to this question, which is good. I'm happy with that. All right, so the next question is, go to question 6. Question 6 says the following: 100 students wrote the June exams. 30 students failed physics, 25 failed mathematics, and 12 failed both subjects. How many passed both subjects? So you know how many students wrote the exams, and you know how many failed in each case, in physics, maths, and in both. A problem like this, I don't know how many of you have been exposed to Venn diagrams, but Venn diagram is a very nice way of capturing this information. What you do is you draw two circles or any two objects. I'll draw two circles. Straight on the side. Okay. And then let me take out these things. Right, and this circle here, one of the circles will represent all those who failed physics. So this circle here is all those who failed physics. And this other circle is all those who failed maths, right? The part in between are those who failed physics and maths because they belong to the physics section. They also belong to the maths section. And here, the people who I'm pointing to here, they failed physics, but they are not in this circle, so they would have passed maths. And likewise, you can make a statement here like this. All right. Now, altogether, there are 100 students. So we can put these students are all sitting inside another bigger box. And this bigger box is the population of the school. So there are 100 students altogether in the school. So this box here, 100 wrote the June exams. So this box has got 100 people altogether in it. Now, amongst these people, you've got the physics, the maths. I want to concentrate on this. 12 failed both subjects. So if this is the physics one, we'll put a P here to show that these are the people who failed physics, all these people in the circle. And these are the people who failed maths. There are 12 who failed both. So 12 will have to be in here. All right, so that's a starting point. Because now you can say there were 30 students who failed physics altogether, and 12 of them are here. So 18 would have to be on that side. Likewise, 12 failed mathematics, but 12 failed both. And altogether, there are 25 people who failed mathematics. So there are 13 in that lot. See? So it means that 13 people who failed mathematics, but they passed physics because they are outside the physics block. The question here is, how many passed both subjects? That's an interesting question. If they passed both subjects, what does this mean? Let's translate this into failing, because this is all about how many people failed. If they passed both subjects, what does that mean as far as physics and maths are concerned? It means that they did not fail physics, fail physics. And they also did not fail mathematics. That means these people are not inside the P set, because these are the people in the P set, and they're also not inside the M set. Right? So in other words, they're not anywhere inside these circles here. They're all outside. So altogether inside the circle, you got 18 plus 12 is 30. You got 43 inside all these. There were 100 people altogether. So there were 57 people, because there are 43 here. So there are 57 outside. So these people who are outside are precisely the people who passed both subjects. The person here is not inside the circle here, so he's past physics, and he's not inside the maths, so he's past maths. So all the people outside have passed both subjects. So the answer is 57. That's the number of people who are outside. Okay, by show of hands, if you can show me how many people got 57. Okay, so I'm getting a, oh yeah, okay, so we got a few more. Now I'm getting a sense as to how many people actually try to solve these problems, because there are a number of you who have not tried. I can say that because I'm getting the same number of people who are raising their hands in both cases. Now, please don't do that again. The next week's session, you got enough time. And Patrick, can you hear me, Patrick? Are you still there? I think Patrick is from the South African Maths Foundation, who stepped in earlier. He seems to have stepped out now. Okay, let's get on to the next question. Question 7.
Yes, I got you, Prof.
Oh, you are here. Okay, okay.
Yes.
Oh, sorry, Patrick. You are going to put up session 2 questions as soon as possible. Okay.
Yes, that is.
So they will have the whole week to look at it.
Yes, yes,
Yeah.
definitely.
So you'll have enough time to look at the questions. And next time when you come in, please make sure that you try them.
Okay.
Thanks for that, Patrick.
Okay, Prof.
All right. So we go on to question 7 now. The question 7 says, consider the pyramid of numbers in the diagram. What is the second to last number in row 6? So how are these numbers created? You see, in the first row, there is one number. In the second row, there are 3 numbers. And the last number in the second row is 1 plus 3. I'll say that again. The first row, there is one number. The second row, there are 3 numbers. The last number here, you're counting it, 1, 2, 3, 4, you see. So the last number in the second row is the full count, 1 plus 3. Which means this is the last number in the second row. Now, if you look at the last number in the third row, it's 13. How did we get 13? Because we added these 4 numbers, 1 plus 3. We added 9 more numbers to them. Right? These 9 numbers. And those 9 numbers are in the third row. So altogether, you've got 1 plus 3 plus 9, which is 13, and that's the last number here. So the point is that we can actually calculate the last number in each row simply by adding, and what? Now here, the next pyramid will look like this. You're going to have 3 prongs at each place, right? At each spot. I don't have space. Here too, you're going to have 3. So the next one will have 27 numbers in it. And when you add up all these, it'll be the last number of the 4th row. This is the 4th row. The question is, which is the second to last number in the 6th row? So we need to go on. In the 5th row, you got 1 plus 3 plus 9 plus 27. That's 40. Plus, the next one will be 81, because each of these 27 will have 3 prongs to it. So that's 121. And then in the sixth row, it'll be 121. And then you got the number of numbers in the sixth row which are added is 81 times 3. This is the number of numbers in the sixth row. And if you add it to all the numbers in the previous row, you get 364 when you add these numbers. So what does the 364 represent? It represents the last number in the sixth row. First, second, third, fourth, fifth, sixth. The last number is 364, sorry. The very last number in the sixth row is 364. But the question is, what is the second to last number in row 6? It would have been the one just before that. 364 is the last number. So the second to last will be 363. And that's the answer to question 7. Okay? If you have any queries, as I said, just jot them down. And at the end of the session, right, we will address those queries. So, and as I said earlier on, it's just to maintain continuity that we will adopt that procedure, and also because we've got a large number of participants, 91 to be precise, in this session. All right. Next problem is problem number 8. Now, what is problem number 8? Question 8. Question 8, an interesting question. It tests to see whether you really understand what graphs are all about in the real world. So there's a graph drawn here, and this graph says, the graph describes a 6-hour trip that Herman recently took. What was his average speed in kilometers? Now that's quite a mouthful. And if you have not seen anything like this, you will say, how the heck are we going to answer this question from a graph? Right? So let's unpack what you mean by this graph. You see here, can you all see this picture? Is it clear enough? Any one person can answer?
Yes, Prof.
Yes, Prof, we can see it. Yes.
Can you read this time in hours and distance from?
Yes, Prof.
Right.
Distance from home in kilometers 20, 40, 60, 80, 100.
Okay, thank you very much. Okay, now let's try to unpack this. What he's saying is that Herman, he recently took a trip and he is calculating the distance he travels after different periods of time. So as he starts from at 0, he has not traveled at all. So he said the distance is measured along the vertical and the time along the horizontal. At 0, he's still at home. But now as he moves from 0 to 30 minutes to 1 hour, he plots this point because he's traveled now 40 kilometers. So after 1 hour, he's traveled 40 kilometers, right? So at different points here, he has traveled different distances. Now then he continues for the next 1 hour, he carries on. And at the end of 2 hours, he's traveled 120 kilometers. Right. Now at the end of 3 hours, here, he's still at 120 kilometers. What does this mean? If he was traveling from Durban, then it means that this guy is sitting in the restaurant there in Bergview. Okay, he's traveled 120 kilometers and he's not traveling at all for the next hour from 2 to 3. He's having something, he's resting, going to a restaurant probably. Okay, but now what happens is now in the third hour, he starts, his distance from home. Now he's now closer to home. As he's coming down, he's 100 kilometers. And he's coming down, and after 4 hours is here. He's 60 kilometers away from home. And something happened. He decided his distance from home now starts increasing. So he goes back to where he started. Can you see? I think he left his cell phone behind. So he went back there, and then now he really is shot through very quickly. In the next 1 hour, he came right down. In the next 1 hour, from 120 kilometers, he came home. So he was traveling 120 kilometers in 1 hour. He's traveling very fast, you can see. So here his speed was 120 kilometers per hour. Right? That is the average speed. Which meant that sometimes he exceeded the speed limit. But he was not caught by the policeman. Why? Because he never stopped at any given spot. Otherwise, there would have been a time period where he was not moving at all if he was stopped by a policeman. So you can see this little thing here tells the whole story. It's very interesting. That just by taking a situation, you can work out what he is doing. Now, average speed. How do you calculate average speed? The average speed is the total distance divided by the total time. So the total distance he travels is, you have to look at the total distance he traveled altogether. In the first 3 hours, he's traveled 120 kilometers. Or if you like, let's do it hour by hour. In the first hour, he's traveled 40. In the second hour, he's traveled from 40 to 120. So he's traveled 80 kilometers in the second hour. In the third hour, he traveled nothing because he didn't move at all. But in the fourth hour, he traveled from 120 to 80, to 60. So that's in the fourth hour. In the fifth hour, he travels another 60, from 60 to 120. And in the last hour, he travels 120 kilometers. So he travels various distances in different hours. So he's getting various average speeds. But this total average speed will be, you add up all these things and divide by 6 because he's going through 6 hours. So if you add up all these things, you get 120, 240, 360. So it's 60 kilometers per hour. That is his average speed. Okay, I think that was a very interesting question. How many of you were able to get 60 kilometers per hour? That will be interesting to see. That's very good because it's, I see many more people have got, well, at least 50 participants, which is very good. Because this was not an easy question. It is it's not a non-routine question, what you call a non-routine question. You don't see this kind of a thing occurring in school maths, I don't think. Okay, so we now go on to question 9. The difference between the square root and the fourth root of a number is 12. What is the number? Okay, and this is another example of, you might want to use x and say, let x be the number. If you did that, you'll say, let x be the number. Then the distance between the square root and the fourth root will be smaller. that difference is going to be 12. The square root and the fourth root. Now, it's almost impossible to solve this kind of a complicated equation. But the idea is, if you think about it, you say, well, I'm going to look at numbers which have got fourth roots. So what does that mean? The numbers which have got fourth roots are fourth powers. 1 to the 4, 2 to the 4, 3 to the 4, 4 to the 4, and so on. These numbers have got fourth roots. So let's look at these numbers. These are possible values for x. Right? Okay. Now, what is the square roots? What are the square roots? The square root of these numbers are 1. And here it will be 2 squared. And here it will be 3 squared. And here it will be 4 squared. And here it will be 5 squared. So these are the square roots of x. And the fourth roots of x are, well, it's easy. It's 1, 2, 3, 4, 5, and so on. Right? Because the fourth roots of a fourth power are just the originals. And the differences are, you can see, the difference is 0 here. So that's out, 2, 6. And this is the only one which has got difference 12. 16 minus 4 is 12. And after that, the difference gets bigger and bigger. So this is the answer to the question. The number that we're looking at is, you're looking at the number, that one. That's your x, right? Because the fourth root, the square root minus the fourth root of that number is 12. 4 to the power of 4 is 16 times 16. 16 times 16 is 256. So that's the number that we are looking for. All right, once again, let me take a check on this to see how many of you got 256. All right, I'm happy to see that there are many of you who are getting the answers. So that's the answer to question 9. Well done. Okay, now we go to question 10. The question says, if the repeating decimal, 0,77777 and so on, is expressed in lowest terms as a over b, the question is, what is a plus b? So you're writing a decimal number as a fraction, but this is an infinite decimal. Now, I don't know how many of you recall what you did in earlier grades, because you are senior students and you are from grade 10, 11, and 12. But in earlier grades, you would have done recurring decimals. And like, for instance, this one here, this number here is really 7 over 9. If you had, like, for instance, 0,33333, this is 1/3. Right? When you write 1/3 as a decimal, this is what you get. And that's the same as 3 over 9. See, you take 3 and you put it over 9. Okay. So this here, this number is 7 over 9. Or if you're like, the 1 over 9, if this is 3 over 9, then 1 over 9 is 1, 1, 1, 1, 1, and so on. And therefore 7 over 9 will be 7, 7, 7, 7, and so on. And this is already in lowest terms because you can't simplify this any further. So A will have to be 7 and B will have to be 9. So A plus B is 7 plus 9. So the answer to this question is 16. Now, the interesting thing here is these recurring decimals. I'll just digress a little bit. If you did geometric series, I think in grade 10 and grade 11, you do geometric sequences. Let me just talk about this a little bit. I'm going to use the whiteboard for the first time. All right, a geometric sequence is a sequence of the form AR squared, and so on, right? And the sum of a geometric series sequence, there's a formula for the sum to n terms, and there's also a formula for the sum to infinity. It's A over 1 minus R. This is all in your school curriculum. The sum to infinity, that is provided that the R, the ratio mustn't be too large. It must lie between -1 and +1. Then only you can use this formula. Otherwise, you're not allowed to use this formula. You can only use the formula if you know that the ratio lies between -1 and +1. So in that context, this number 7, this repeating decimal is really, the first 7 is 7 over 10, plus the second 7 is 7 over 100. If you add these two, you'll get 70 over 100 plus 7 over 100, which is 0.77, right? These two will give you 0.77. Okay, if you go on like that, the next one, you'll have to add it as 7 over 1,000. That will give you 0.777. And we just go on like this because this is an infinite decimal. And that's exactly like what we've got here, right? You got your A is the first term, and R is a common ratio. What are you multiplying each term by? You multiply this by R to get to this, multiply this by R to get to that, and so on. And you're multiplying everything by 1/10 here, you can see. So R is 1/10 to get to the next term. So you got A is equal to 7 over 10, and R is 1 over 10. And this number certainly lies between -1 and +1. So therefore, we can use this formula, right? This formula here is 7 over 10. That's your A. 1 minus R. R is 1 over 10. And that's the sum. So to simplify this, multiply the numerator and denominator by 10 to get rid of the fractions. Multiply numerator and denominator by 10. The fraction doesn't change when you multiply numerator and denominator by the same number. If you multiply the numerator by 10, it's 7. If you multiply the denominator by 10, you have 10 minus 1. And that's how we get 7 over 9. You see? So that's the background to where the 7 over 9 came from. And it's an application of infinite, the sum to infinity of a geometric sequence. Okay, let's get on to number 11. Number 11 is a rather long kind of a problem. Let me, I keep forgetting to get back to my original questions. Okay, so we're back on the screen. Question 11 says, Andy has a number of red, green, and blue counters. Okay, I made these counters here red, which shouldn't have been, maybe just imagine that they are black. So you have a thought experiment here. All right. But he's got a number of red, green, and blue counters. He places these 8 counters equally spaced around a circle Like, okay, this shows how they are placed. And if you count them, you see there are 8 counters. So this is what he has done. But he's got, these colors are not red. They got red and green and blue, so they vary. These colors are chosen from 3 different colors. But there are some rules. 2 red counters may not be placed next to each other. 2 green counters may not be placed diagonally opposite each other. And the question is, what is the smallest number of blue counters that Andy will have to use? Okay, so this seems to be quite a complicated problem. So let's see what we can do with this. I want to go on to my whiteboard again. So let's clear this whiteboard.
Sorry.
Yes. Yes. Okay, somebody wanted to say something and stopped. So I'm going to draw the, just hold on, please. Okay, I'm going to redraw. Is somebody trying to say something? All right, I think they had the mic on accidentally. I'm going to redraw this circle and put my counters there and try to actually reconstruct what is being done here. So what we have here is a circle. So let's draw the circle. And we're going to place our counters, the 8 counters. I'm going to place the 8 counters equally spaced along this thing. Let me just draw these diagonals. Diameters. So I'm going to divide it into 8 equal parts. So first I'll divide it into 2 equal parts, then 4, and then 8. Okay, so I'm going to place my counters. There are 8 spots on the boundary, and let's go back to the question now. I need to just navigate between this and the question. Right. The first rule is that 2 red counters may not be placed next to each other. All right, let's observe that. 2 red counters may not be placed next to each other. And I'm going to go back to my whiteboard and share it with you. So let's just place a red counter here somewhere. Suppose I place a red counter here. Okay, look, I don't want to, the question is, let's go back to the question. The question is, what is the smallest number of blue counters that Andy will need to use? So we're going to try to avoid using blue counters as far as possible to get the smallest. I'm going to use only the red and green, right? Because I want to avoid using blue counters. So let's start with, say that we've got 1 red here. And we said that two reds cannot be next to each other. So this has to be green here. You cannot have a red next to this red. Okay, so this is where we are. Let's go back. We can't proceed any further because we can't say anything about the green. Let's go back to our question. And we're finished with that. Two red counters cannot be placed next to each other. Two green counters may not be placed diagonally opposite each other. Two green counters should not be directly opposite each other. So let's just look at that again. Now I have a green counter. So I cannot have a green here. Right? That's what the third condition says. Because you cannot have two greens directly opposite. So I need to have a red here. Likewise, this green here directly opposite it, I need to have a red here. Okay. I'm not putting blues. I'm only putting reds and greens. I'm trying to avoid blues. I want to minimize the number of blues. Okay. Now that I've got a red, I'm not allowed to put a red next to it. Okay. Again, I insist on putting a green. And here too. Oh, sorry. Just one moment. Okay, you may want to put green, green. Now, I can put a green here. That's not a problem. Right? And I can put a green here. So the reds, there's no red next to this. But I can't put a green here because there's a G here, you see. I'm not allowed to put a green here. Neither am I allowed to put a red here. Right? So I am forced now to put a blue here. And that's the only one. It can't, the minimum can't be 0 because I can't put a green here, right? Or a red. So therefore you have to put a blue here. So the answer to the question, what is the smallest number of blues that Andy will put? The answer is 1. You can put 1, and that's the smallest number. You can't put 0 blues. Okay, there are 7 people who have actually solved this problem. Any more? Any others? How many of you have solved the problem? Oh, you've got a large number. I think you guys like these kinds of problems, huh? Wow, over 40 and climbing. Okay, that's very, very satisfying. Okay, now we go on to the next question, question 12. And let me go to the question itself. Okay, at this stage, I think I'm going to give you a short break, 5 minutes. You can go and have a cup of coffee or something like that. But my time says 10:12. So exactly 10:17, I shall be starting again. Okay, so let's have a break.
Prof?
Okay, Patrick.
Yes, Prof. I think you are doing very well today. There are not many questions. Do you think?
Well, I told them not to ask any
very...
questions.
Yeah.
You know
Maybe
what
I could just...
We've got 90 odd people now.
Yeah.
Everybody will put in, and you can go on for half an hour.
Yeah.
I don't
Yeah.
want to do
Yeah.
that. I want
Okay.
them to ask a question in their own free time. So at the end
Okay.
of the thing, those who want to go, they can go. They're quite free to go. And the others
Yeah.
who want to stay back and listen to any other discussion, they're quite free to do so. And they can ask questions at that time.
Yeah.
It
Yeah.
works very well. I did that
Yeah.
with the
Yeah.
juniors
Yeah.
yesterday.
Yeah. Yeah. And you're able to do a lot of problems as well. I think for me, I'll just check at the end of the lesson at 11 o'clock just to see if there are anything that needs to be done. I'll just leave you to it until the end of the lesson.
Yeah. Oh,
Yeah.
you know, I didn't switch off my mic. Not the mic, the recording.
Oh,
Okay,
great.
let me just get to that. The problem with recording is that you tend to forget.
Yeah. Yeah, that's true. Yeah.
Um,
I'll just come back around 11 o'clock just before
yeah,
you
yeah,
close. Okay. Yeah.
no problem.
Okay, Prof.